Welcome everybody to the third in this week's series of GeoMapApp webinars. Today, in this first webinar today, we'll be focusing on polar regions, looking at some of the capabilities that GeoMapApp offers for the polar regions. Just before we get started properly, we'll spend a minute waiting for a few other people to sign on to the webinar system. And if Carla at MGDC is online, could you just use the question box to tell us if you can hear me okay? Okay, so we have confirmation that I can be heard. That's good. In the GoToWebinar panel, you'll see that there's a question box area, and as we go through the webinar, if you have questions, please type them in there, and my colleague Leslie Shee will compile the questions, and we'll do our best to answer them as we go along. Oh, I should introduce myself, Andrew Goodwillie at the Integrated Earth Data Applications Group, AIDA, which is housed at Lamont Doherty Earth Observatory. The webinar will hopefully be around 45 minutes, maybe a bit less, and we're recording the webinar, and we'll be putting the webinar up online probably next week. So if there's something in the webinar that you don't quite catch, you'll be able to look at it online at a later date. Okay, so let's get started. Let me get rid of the slide here. And I'm assuming that everybody received my message a few days ago with the instructions for downloading and installing GeoMapApp. So hopefully you have GeoMapApp over on your screen. And for this webinar, you can follow along if you wish, or you can simply watch the webinar and watch the webinar in the future time and go more slowly through it to go step by step. So I'm going to double click on the GeoMapApp icon. And the first thing we see is a choice of 3 different projections. The default is a Mercator projection that's over here on the left. Then we have a South Polar in the middle and a North Polar projection. And for this webinar, let's choose the South Polar view. So we click once in this map, and the map is highlighted now in blue, and hit the Agree button. And the GeoMapApp window opens in the South Polar view. So let's have a look at the layout of this window. In the main part of it, we have a base map. We'll talk about that in just a second. Along the top is a row of menu items, and if we click one of these menus, for example, data sets, we see a whole bunch of things under that menu. Data sets that are built into GeoMapApp, and we'll be exploring some of those as we go through this webinar. Beneath the menus, there's the toolbar, and here we have a row of icons, and if we let the cursor hover over any of these icons, we see what it does. So there's the zoom in, zoom out. This icon tells us it's the distance profile tool. Here we have the grid line control, so we can turn this on and off, for example, and we'll look at some of the other ones as we go along. As the cursor is moved around in the map window, you can see at the top of the map window, just in this space here, there is the latitude and longitude of the cursor position. The first pair of numbers gives the longitude and latitude in degrees and minutes, and the second pair over here on the right gives it in decimal degrees. So the base map comprises a range of data sets. On the land we have the SRT and the Space Shuttle Radar Topographic Mission 30-meter data, so every 30 meters there's an elevation point on the continents here. And in the oceans we have a mixture of cleaned multi-beam swath bathymetric profiles, as well as we use the BedMap data set for Antarctica. And in some places there are contributed grids where researchers have sent grids to us for inclusion in the base map. And we can explore the places where we have detailed swath bathymetry, for example, by clicking one of the icons in the toolbar, this one, the third from the right, which is the masking function. If we click this, most of the map turns grey, and these grey areas in the ocean are where we have the background Smith-Samuel predicted bathymetry data set. The places where we see the transparent areas are those where we have the higher resolution processed multibeam bathymetry. So let's go and zoom in on one of these areas, and we'll look at this area between the Bellingshausen and Amundsen Sea. So for now I'll keep the mask on, it just makes it a bit easier to navigate in the polar oceans. And I'll activate the zoom in button, which is the fourth one along here. So now we've activated the zoom, and to zoom in I can either click on the map or I can draw a rectangular box, it doesn't matter. So in this case I'll draw a rectangle, then I'll click a few times, and the GeoMapApp application is going to the server and is pulling across the relevant resolution level for this zoom. So here we see that the more we zoomed in, the more detail was displayed on the map. And in this case, we can see some pinkish areas. This is a pre-made JPEG image, which is quite quick to transfer over the internet. And it's made according to a color scheme that we specified for the whole world. So for this relatively shallow region, the colors don't show that much detail. When I move around in the map, the mouse position is shown in the top, as we saw before. And for now, I'm going to take the mask off. And if we look first at the gray areas, when we remove the mask by unclicking that, we can see that they are the much lower resolution background areas. Okay, so we have this image of the, in this case, the seafloor topography in this part of the Antarctic margin. But because it's a pre-made image, then it's not really that useful in terms of manipulating or analyzing the underlying data. So we're going to load the underlying three-dimensional digital elevation model. And the base map is something called the Global Multi-Resolution Topographic Synthesis. It's a product that the AIDA group at Lamont makes. And we update it once or twice a year with new data. And when we load the underlying grid, the gridded dataset digital elevation model, then a whole range of extra functionality becomes available to us. So for this, I'm going to deactivate the zoom, just in case I click on the map and when I didn't mean to. And in the toolbar, there's a shortcut over here, the little waffle iron symbol. And when that is clicked, the grid, the third dimension value, is going to be loaded in GeoMapApp. There we go. So a few things happened. The map changed color, a layer manager window appeared, and we'll look at that functionality later. So for now, let me minimize the layer manager window. And somewhere, there we go, behind the map, there was another window, a global grid window. Now, this window allows us to control the grid functionality. So, in the middle of the window, we see a histogram that shows the distribution of the color palette based on the elevations, in this case, for this particular area. And if we look carefully, we can see two thin gray lines, and by dragging these lines around sideways, we can change the color palette very easily, like so. We can also change the vertical exaggeration, and this will enhance the artificial illumination in this map. So in this area, the VE area, vertical exaggeration, let's bump this up, say, to a factor of 4. And there we go. The shadows became much more prominent there. We could also draw contours on this map. There's a contour function over here. Clicking once on this brings up a contour window. And we can change the values that are presented in the window. So let's say we want to draw 50-meter contours between 1,000 meters and 500 meters depth. We hit OK, and now we have the contours drawn on top of the gridded bathymetry. Then we can turn those contours off simply by clicking again on the contour icon. And another very useful feature when we have a grid, any grid loaded, is the artificial illumination. That's over here. The yellow dot represents the location of the sun, and we can drag the sun around to change the direction and angle of the illumination. So when we look at this map, we can see these features that trend in a roughly northeast to southwest direction. These are glacial scour marks on the sea floor. And if we move the artificial illumination over, say, to the northeast, then many of those features are now being illuminated along their trends, so they disappear. And similarly, we can move it down, say, to the southwest, and there they are again. And another fun feature with the grid loaded is to be able to generate a profile across the grid. There are two ways to take a profile when we have elevation information loaded in GeoMapApp. Up in the toolbar, up here, there's a little symbol right in the middle of the toolbar, the distance profile tool, and that's actually a shortcut that will load the underlying digital elevation model and activate the cursor ready to take a profile. The other way is in the grid control panel, and the same icon appears next to the contour icon, and this one works on any grid that is currently being viewed. So in this case we're looking at the elevation model. It could be if we had a gravity grid loaded, for example, or a magnetics grid, whatever it might be, we could take profiles across that grid. So let's activate the profiling tool. And now, going into the map, we click once at the start of the profile and drag the cursor, and when we let go, the profile instantly pops up. With having the grid, the underlying third dimension loaded, we notice that in the top of the GeoMapApp window, just above the mouse here, is the third dimension is displayed there. So in this case, right beneath the mouse, it's 1,145 meters. And over here it's 903 meters deep. And when we move the cursor in the profile window, that same number is listed right here next to the latitude and longitude. So we always know where we are on the map and what the value is of the third dimension of the loaded grid. If we wish to specify exact start and end points for the profile, we can do that using the functions in this part of the map window. And to save the profile window, there's a Save button over here in the upper left, and there are various options for saving the profile in an image format or as a table, tabular data. Let me close, or let me just move the profile window out and show if we want to save the map as a whole. Then if we go to the GeoMapApp menu, the File menu, down to the Save Map window, we have options here to save this displayed map area, just as we see it on the screen. And the PNG format is a bit higher resolution than the JPEG, so if you're making pictures for a poster or a publication, that might be the better option. So let me quit the profile and just go back to the grid control panel. One more feature that I want to show is the ability to change the color palette. We saw that by dragging these vertical lines sideways, we can change the displayed color. There's also a range of color palettes built into GeoMapApp. For example, there's a black and white one, a rainbow color palette, and the user has the ability to import or even export a color palette of their choice. Okay, so that's the basic functionality of GeoMapApp zooming, going to a particular area, generating profiles, loading the base map grid, and manipulating the grid. Are there any questions at this point? So if there are no questions, it doesn't look like any are coming in, great, we'll move on. So for this, I'm going to close the grid, and I'm going to zoom out so we see the whole of the South Polar region. For that, I go to Bookmarks, the Bookmarks menu, and the item there is Zoom to Global Scale, and that takes us right out back to where we started. So if you received my email a few days ago and downloaded the various files for import, I invite you to follow along on your computers for the next few minutes. We'll look at importing a spreadsheet, a shapefile, and a grid file. And you can perhaps foresee yourself doing this with your own data sets. So first off, let me go and find the spreadsheet. So I navigate to the location of the spreadsheet. So it's just a regular spreadsheet, except the top row, the very first row, contains the column headers. And this spreadsheet is a geochemistry data set that was downloaded from the EarthChem portal. In the first column we have some sample ID information, we have some other columns, then we have a latitude and a longitude column. And these are necessary so that GeoMapApp is able to plot the points on the map. Then further over in the spreadsheet, we see the geochemical analyses for these particular samples. So it looks like the spreadsheet is in a good format to be imported to GeoMapApp. So I'll get rid of that. And to import any sort of tabular data, spreadsheet or a comma or tab-separated ASCII file, for example, we go to the File menu and we see various import options. We can import data from a web feature service, WFS, or a web mapping service, or the three we'll look at today are the grid file, shapefile, and spreadsheet formats. So I select the table or spreadsheet and go over and find the option for the Excel formatted spreadsheet. In the navigation window, I need to go and find the spreadsheet. So I navigate to that particular place, and here it is, EarthChem Antarctic Peninsula, and hit the Open. So a window comes up saying the file is being read, and it's now being read, and I hit the OK button. And this window just gets the user to check that the latitude and the longitude column were correctly identified by GeoMapApp. In this case they were. Had we labeled those columns something else, then we would need to use the drop-down menus here to go find the column header that corresponds to the latitude and longitude. So everything looks good. We hit the OK, and three things happened. First, the location of the points is now displayed in the map. Over on the right, we see a control panel with some functions that we'll look at. And down at the bottom, we see the contents of the spreadsheet. So let's zoom a bit closer on these dots. So I click on the zoom function, and I'll draw a box around them like so. There we go. So here we are, we have some rock sample geochemistry on the tip of the Antarctic Peninsula. And I deactivate the zoom so I can click on the map without zooming anymore. And if we click on any of the symbols in the map, the relevant record is highlighted in the table below. We can also go the other way and click any of the records in the table, and it will light it up in the map. So at present, we're just looking at gray circles on the map display. We can start analyzing the contents of the spreadsheet using the functionality in this right panel. Let's say we want to color these symbols on the alumina content of the analyses. So I should show what I just did. I went over and I hit the color button, and this window appears. And we scroll down and we find the column upon which we wish to color. So alumina, there it is, Al2O3. And we hit OK. And the symbols change color. And we have a color palette window opened up as well. So just like we did when we had the grid loaded, we can drag these lines around to change the range of colors on display, like that. So now we have these geochemical data values plotted on the map and colored according to one of the parameters, in this case alumina. let's say change the color, the size of the symbols based upon one of the other parameters, for example, magnesia, MgO. For this, we can use the Scale button, and another window pops up with the column headers. We go down until we find MgO, there it is, and hit the OK button. So right away, the symbols change size depending on their MgO content, and we can change the scale, like sliding those lines around. Okay. So now we have the geochemical data plotted on the map, colored by Illumina, scaled by MgO. So if we wish to generate a map of this, an image of this map, we can go to the File, Save Map window, and there we see those options to save that particular image. We can also create a legend for the colored symbols here. And since we have lots of columns of numerical data in the spreadsheet, we can use a graphing function that's built into GeoMapApp to graph any two of the numerical columns against each other. When we select the graphing option over here, we get to choose the x-axis. So let's say we want to plot silica against K2O, and that is down here at the bottom. And we hit OK. And there we have the symbols plotted on a scatter plot. And notice that the symbols are colored and scaled according to the coloring and scaling that we imposed earlier on. We can change the graph axes here by clicking on these blue lines at the edges and changing the range of axes. And if we wish to select some of the values in this graphing window, there's a lasso tool. Once activated, we can use a freehand drawing mechanism to select all the values that fall within that region. And the selected values are highlighted in the table below, and you may not be able to see it on the GoToWebinar screen, but the symbols that were selected are now highlighted in white on the map as well. And we can save that selection using the Save button at the bottom of the right panel there. Okay, so that's one example of importing a tabular data set. In this case, it just happened to be EarthChem geochemistry, but it can be any geospatially registered tabular data. Are there any questions on that functionality? Okay, so here I'm going to close this function, this tabular import function, by hitting that close button up in the upper right. And I'll go to Bookmarks, Zoom to Global Scale, and we're back to the original map. So in the second example, we'll look at importing a shapefile. So let's go find the shapefile. Let me see. Go up one in the shapefile. So I've got two shapefiles here, one from Reno 2008 paper, and another one which is Southern Ocean Fronts, Oceanographic Fronts. And for a shapefile import, we need three of the shapefile components at a minimum. We need the .shp file, the .dbf file, and the .shx file. And shapefiles often come with more components, but we need those three, otherwise we would not be able to import them to GeoMapApp. So let's go to the GeoMapApp window and see how we can import the shapefiles. Under the File menu, in the middle we see Import an Esri formatted shapefile, and we're going to do it from the local computer. And we use the navigation window to go find the shapefile. So let's first load in the glacial divide shapefile from Reno et al.'s paper. And we hit the Open button. And instantly the shapefile appears. We can zoom a little bit to see a bit more detail. Okay, so this shows the glacial drainage basins around Antarctica. And by activating the shapefile in the shapefile manager, then we can choose its components from the area on the right here. like so. Okay. Whilst we're here, we might as well import the second shapefile. So we go back to the File, Import Shapefile option from the local file system, and this time we'll choose the Southern Ocean fronts dataset. So we need the .shp file for that. It's over here, and we hit OK. And there, around Antarctica in the Southern Ocean, is the front information. And like before, if we activate that shapefile in the Shapefile Manager, we can click through and see the different components, like so. Okay. So any questions on importing shapefiles? No? Great. Let's move on then to looking at importing a grid. So I'm just going to minimize that, and we can keep the shapefiles in the GeoMapApp window, that's no problem. So for the grid, I'll just show what the folder looks like. Let me navigate to that area. Okay, so here we have a grid that was donated by Fred Davey, and it shows part of the Ross Sea bathymetry. And in this case, I see that it's an Esri ASCII formatted grid. The other types that we can import are Esri binary format and the NetCDF format. And the NetCDF format may be familiar to some people as a result of using GMT or MV system software. So there's the grid that we wish to import, and we'll again go to the File menu, import the 2D grid file, and again it's from the local file system. And when the format window comes up, we have to choose the correct format. So here it's the Esri ASCII format, and we hit OK. And in the navigation window, we go and find the gridded file. There it is. And we hit Open. So at this point, GeoMapApp has read the header information for the grid file and is displaying what it found. So here we see the west, east, south, north boundaries. And in this region at the bottom of this screen, we see the minimum and maximum Z values associated with this grid. In this case, it's bathymetry going from 3745 meters up to a shallow 44 meters. And the functionality here allows us to apply a scale factor to every value in the grid. For example, if we'd received this grid with depth being defined as positive downwards, we may want to switch it to be negative downwards by applying a factor of -1. So if everything looks good here, we just hit the OK button, and we see, so, oh, things happen very quickly there, so let me just explain what happened. First off, let me open again the folder where the grid resides. So that was our original file here, the original Esri ASCII formatted file. And we see some other folders and files were generated. These are internal files for GeoMapApp, and they allow GeoMapApp to zoom in and out on the grid and showing the relevant amount of detail at each zoom level. So if you wish to import a second grid, you would need to place it into a separate folder, otherwise these internal files will get overwritten. But there is the functionality to import multiple grids at one time. And there's a YouTube video that demonstrates that. Okay, so let me minimize that window and look what else happened. So there we see the grid loaded in the window on the map, and we can zoom on this area. The zoom button is already active, so I can just click and zoom in a ways. And I'm going to untick the zoom, reverting to the cursor, so I don't zoom in anymore. And we can see that this grid is overlain on the base map. If we open the Layer Manager window that popped up earlier, if we can't find it, we can just hit the icon at the end of the toolbar, and that will bring it back up. We have the ability to either turn the grid on and off, like so, or we can use the opacity scale to change the transparency of the layer. So if we grab the little symbol here and drag it one way, we can make that layer more or less transparent. So that's a very good way, a very useful way to compare data sets in one location. And we can also use these arrows at the side to promote one of the layers up to the top. So if we had other information in there that we want to put on the surface of the map, then we can use the up and down arrows accordingly. And because we loaded a grid, all of the functionality that we explored earlier with the color palettes, the artificial illumination, the contours, profiles, vertical exaggeration is all available to us. So let's change this vertical exaggeration, say, to a factor of 10, and we can take a profile across it, like so. So here we're demonstrating how we can import a grid from our local computer and use all of the built-in functionality to manipulate and explore and analyze that grid. Okay. Are there any questions on importing grids? A great question just came in from Walter. Thanks, Walter. And the question was, if a user imports a data set, does that data set become automatically available to other users? No, that's not the case. If a user wishes to donate or contribute a data set to GeoMapApp, we can build it into the built-in data sets, and then it would become available. Otherwise, the import functions are in operation only for the session, the GeoMapApp session at that moment. So if we now close GeoMapApp, we would lose that imported grid. There was a question about, can we query a grid to check the values in the grid? Yes, to the extent that, let me just get rid of this profile window as I minimize the layer manager. Just like before, as the cursor is moved around over the grid, the imported grid, we see that the value, just here in the top bar, the value changes, and that reflects the gridded value. So, for example, let's say I'd imported a grid of ice thickness, or carbon dioxide concentrations, then those values would be displayed in the top, wherever the mouse is moved to. Hopefully that answers the question. Okay, so that's demonstrated the three main ways to import data that a user most commonly uses: importing a shapefile, a grid file, and a spreadsheet. And now we'll spend the remaining 10 minutes or so looking at some of the built-in data sets. So we can either go through the layer manager and close all of the data sets, or if we wish, we could just hit the big red X in the GeoMapApp window to get rid of the window completely, and we'd start another GeoMapApp session. So I'll exit cleanly, and I'll just delete the items from GeoMapApp there, and then I'll go to the bookmarks, zoom to the global scale, and here we are back to the start. So let's have a look at some of the contents of the menus in GeoMapApp. First, let's look at coastlines. There's always a problem around Antarctica. If we look in the Overlays button, we have a coastlines option down near the bottom. The three options here are low resolution. Let's click on the SCAR medium resolution coast. It takes a second. We can see the processing status bar there, and there we have the medium resolution SCAR coastline. Now in the layer manager window, which appeared, we see that there's an information symbol in the middle. Clicking this symbol should bring up information about that particular data set. And that is true for just about all of the built-in data sets. We provide the hyperlinks that take the user to the original source. Okay. So that's loading the coastline. Another built-in data set is ice extent, the extent of sea ice throughout the year, and that is located in the Base Maps menu. Now, clicking on the Base Maps menu, we see that there's this thing called tear-off menus at the top, and we can either go through the menus and use the cascading menu options, or we can click on this tear-off menu option, a new window appears, and it makes it a bit easier to navigate the menu structure. So let's go into Regional Maps, Antarctica, and it's a bit wider. We see that there's a sea ice extent option, and we can choose, say, March, which should be the minimum extent for sea ice, give or take. It's loading the data set. And there in light blue, we see the March extent of sea ice around Antarctica. And we can load the September sea ice extent, and no surprises here, this is probably the maximum extent. There it is, so way more sea ice in the austral winter. Now, before we looked at the transparency with grids, and we have the same transparency function available to us in the Layer Manager, so we can drag the transparency bar and compare the March and September sea ice extent in that fashion. Okay, there's a lot more data sets built into GeoMapApp, so let's have a look at some of them. And I'm going to come out of the regional maps and go into the regional grids data set menu. And here we see we have some ice sheet data. So opening the ice sheet menu shows that we have various ice thickness data sets and ice flow velocities. Let's select the BedMap 2 ice thickness. So we click on it, hit the OK button, and various windows open. I'm just going to move the Layer Manager window out of the way. And we know that this is a grid. We saw it listed under Regional Grids. So here we once again have the Grid Control panel. And on top of, let's see, did it load? Let me just check it loaded correctly. Aha. Let me go find my Layer Manager window. Now, for some reason, ice thickness. Let me just try loading the BedMap v1 dataset. Okay, there we go. So I'm not sure, I must have hit something wrong. Let me try bringing in the BedMap v2. I did it just before, and for some reason I cannot seem to get it just now. Okay, so let's have a look at the BedMap version 1 dataset. So here we see the ice thickness is listed. Now, the user before, the person on the webinar, asked if we can interrogate the pixels of the imported grid. So here we're looking at the ice thickness dataset, and as I move the cursor around here, in the top bar of GeoMapApp, we see the ice thickness value is displayed. And because it's a grid, all of the functionality we've so far explored is once again available to us. So we can bump up the vertical exaggeration. We can take a profile, for example, right through there. And here we see the ice thickness along that profile line. Another ice-related data set is the ice flow velocities. So let's have a look at that. So we click ice flow velocities. This comes from a 2011 paper by Reno et al. And hit the OK button. Oh, and for now I'll get rid of the profile window. I don't need that anymore. And there, overlaying on the map, we now see the ice flow velocities. And here, as we move the mouse around, we see that at the top of the GeoMapApp window, we're getting values here of 5 meters per year, 90 meters per year, 481 meters per year, so we can see what the values are. And if we are to zoom in, so let me go and zoom, say, on this area up here. So here we're looking at the ice flow velocity, that's the top layer, and underneath that we have the ice thickness layer, and then we also have the sea ice extent values that are loaded. We can make the ice flow velocity transparent like so, and look at the underlying data set showing the ice thickness like that. So it's a quick and easy way to compare data sets that are co-registered. And another data set that we have built in is the LIMA Landsat imagery mosaic for Antarctica. So let's load this for this area. So in order to keep the area locked, let me just move the layer manager window out of the way. To keep the map locked in this area so it doesn't zoom out to the whole of Antarctica, I'm going to go to the grid control panel, and we'll see that there's a padlock at the top of this control panel. And when the mouse hovers over the padlock, it says click the padlock to lock the displayed area. So let's do that. Okay, so now when we import more data, or when we display and load more data, we should stay in this particular region. So before I do anything, I'll untick the zoom, and then I'm going to go into the base maps window and find the LIMA data set. So it's listed under regional maps, Antarctica satellite imagery, and in this example, let's have a look at the enhanced contrast LIMA data set. So we select it, and we hit OK, and let's see what happens. There we go. So let's move that. Okay. So now we have the LIMA data set on top of the other gridded data sets. Okay, so a couple of questions came in. I'll answer the questions in 1 second. Let me just show the transparency here. So if we cannot find the layer manager window, we can hit it in the toolbar there, and up it comes. And once again, we can use the slider bar to compare the different data sets, looking at this spectacular LIMA image of the ice flow here. Okay, so one of the questions that came in was, can the data be separated into separate screens for comparison? Yes, indeed, there is no limit to the, well, I don't think there's a limit, I've not reached it yet, to the number of GeoMapApp applications that can be run. So here I've got GeoMapApp, the one we've been using all along. I'm going to click on the GeoMapApp icon again, and right away I can load a second one and do whatever I need to do in that window. And I can move it onto my second monitor that you cannot see, but I have 2 monitors here. So yes, that is definitely possible. And there is a question about, can scale color legends, color scales be generated for maps? Yes, they can. There are a couple of ways to do that, and for now I'll just point you to the YouTube videos that show how to do that. Okay, there is one way, I'll quickly show you one way. There's a color scale button in the overlays button up here that will show the colors for the loaded grid. Okay, so we've got a lot of different data sets loaded, and we've got just 1 or 2 minutes left, so I'll show a couple of other functions here. Before I do that, I'm going to eliminate all of these data sets that were just loaded. So let's hit those big X's there and see all the data sets disappear. And of course, I should say that at any time we can just hit the File Save Map Window function to save whatever we have on display. And we'll go back to the global scale for the South Polar projection. And let's have a quick look at the contents for the seafloor samples, the sediment samples here that are in the Antarctic Research Facility archive at Florida State. For that, if we go under Datasets, then we can again hit the tear-off menus from the top, and look down till we see seafloor and lakebed samples, and under there we have samples by archive, and in there we have the Antarctic Research Facility catalog. Clicking on that will load this data set, and now we see the familiar tabular appearance of GeoMapApp with the control panel here and the table down below. And clicking on any of the symbols on the map lights it up in the table, and we see that there's a hyperlink here. Clicking on that should bring up the NOAA record right there. So we see that this is from an old Eltanin cruise back in 1965. Okay. So we also have an awful lot of seismic data for Antarctica. So let me quickly show that. So I'll just close the toolbox, and still in the Datasets menu, there's the Antarctic Seismic Data Library System survey line catalog. And if we load this, this will show us the track lines for the seismic surveys that have been done around the Antarctic continent. It takes a second to load. There it is. And we can zoom and look at all the areas where we have survey lines. And we're working closely with our colleagues in the Seismic Data Library System to get more and more of the non-restricted seismic surveys into GeoMapApp. Currently, we have about 1/4 of the SDLS holdings built into GeoMapApp now. So to look at those particular seismic lines, let me just close this survey track line map, and I'm going to load the seismic section portal, and this portal offers enhanced functionality. So I load the digital seismic reflection profiles. This is the multi-channel seismic data, and move the layer manager out of the way. And we see that various boxes appeared on the map of Antarctica, and the window changed its layout. We have another control panel on the right where we can choose which catalog to look at, and we have two currently empty panes on the bottom. Let's zoom on this area just to the west of the Antarctic Peninsula. And you see that as we zoomed, track lines suddenly appeared. Using the mouse, we can select one of these survey lines, and over on the right it tells us it's a Ewing leg from 1991. In this case it's line 1079. Hitting the Load View 1 button will load the MCS profile into the pane in the lower left. On the map, the selected line that is now loaded is colored yellow, and the red portion shows the extent of the profile displayed below. So as we scroll through the profile, that red line slides up and down on the survey line. And we see the detail here. Now we can zoom in on this, so let's hit the zoom button down in the lower pane, and we can zoom in and see some of the reflections here. And there are functions to allow us to digitize and annotate and save the digitized products from this profile. We can also hit the diskette function here and save the MCS profile, or even download the whole seg.y file for that particular line. And we also have the ability to compare this profile to another one. So let's choose the one that crosses that profile, and we now see the name of this survey profile, and let's load that one into this window down here. There it is. And we see that if I scroll all the way over here, these blue lines show the crossing points of these two profiles. And again, we can zoom in and have a look at the reflectors here. Okay. And as before, we have the ability to save what we're looking at in the screen, or to save the whole profile, or we can save this map window by going to the File, Save Map Window option there. And the very last thing to show is that looks similar to this portal is the radar, the ice-penetrating radar dataset that is built in. So let me close this portal, and I'll go back to the polar view, and I can get rid of that window, get rid of that one, and I go into Portals, and just below the center is the radar profiles. So I load that, and we see in a second when it loads, we see that the map window has changed appearance somewhat. We have a control panel over on the right, and these two panes that are now familiar to us over down at the bottom. So here we have the choice under the Expedition box to click on Vostok or IGAP data. Let's click Vostok, and the survey lines are now plotted on Antarctica, and we can zoom into that area like so. These show the survey tracks for the ice-penetrating radar. And let's click one of these lines. Here we go. So it's X29B, and we can hit the View one, and that will load that particular radar profile into the lower left screen. And there we see the reflections down at about 50 microseconds. Let's zoom in on that area from the lake bed for Lake Vostok. And let's load one of the cross lines, say this one, Y07A, and put that in View 2. And it should be loading, there we go. And there we also see the same lake bed reflector. And once again, that blue line shows us the common crossing point of the two profiles. So that's, we're running out of time rapidly here. That's basically a quick guide to some of the functionality for the polar regions that's offered by GeoMapApp. I will say, if you need help on any of the functions that we've viewed, under the Help menu at the top, there are links. If we click on the, well, there's the Comments and Sections link, and that will allow you to provide feedback to us to help us improve GeoMapApp. And there's also a link to multimedia tutorials. If we click that, a web page opens, and this takes us to videos that we've placed on YouTube, and each of these is a fairly short video, just a couple of minutes, showing the functionality, most of which we've gone through today. Okay, and the last thing for me to say is that once this webinar ends, I'm going to send email to all of the participants with a request to spend about 1 minute filling in a quick survey that we have. It may not even take a minute, maybe just 30 seconds, so we can improve the webinars and GeoMapApp for future users. So thank you very much for your attention, and if there are no more questions, then we'll end the seminar. Okay, I don't think there's any more questions coming in, so thank you very much.